Back in 2017, Earth had a run-in with something straight out of a sci-fi movie. A bizarre object drifting in from the endless dark of another star system. Nobody realized it at first, but this visitor wasn't from around here. It was unlike anything we had ever seen before, and years later, scientists are still trying to figure out exactly what it was. Now, in 2025, history is repeating itself. Another strange traveler is headed toward our sun, and this time, we can see it coming. Things are about to get even wilder. Let's rewind. That first mystery object was called Oumuamua, the very first interstellar object ever detected by humans. Imagine that, something that spent millions of years drifting across the galaxy, only to slip right through our solar system. The craziest part? It caught everyone off guard. By the time astronomers realized what it was, the object had already swung around the sun and was racing back out into deep space. The name Oumuamua comes from the Hawaiian observatory that spotted it. At first, scientists thought it was just another comet, but when they looked closer, they noticed it was missing the glowing tail comets usually have. So maybe it was an asteroid? Wrong again, because its behavior didn't match that either. This thing was moving in a way no ordinary space rock should move. Here's the kicker: the speed. Inside our solar system, everything dances to the pull of the sun's gravity. Planets, asteroids, comets. They're all locked in orbit unless they can break free at insane speeds. From Earth's distance, that escape velocity is about 42 kilometers per second. But when astronomers tracked Oumuamua racing past Earth's orbit, it was tearing through space at an unbelievable 87 kilometers per second. That's more than double the speed needed to break free from the sun's grip. This wasn't just a visitor, it was proof that something from another star system had slipped right through our backyard. That crazy speed we saw? Scientists call it a hyperbolic trajectory. And here's where things get even stranger. Before Oumuamua zoomed past Earth, it actually dipped inside Mercury's orbit, getting ridiculously close to the sun itself. Normally, an encounter that close with the sun's massive gravity should have slowed it down. But instead, as it pulled away, something shocking happened. It actually sped up. That's not just unusual, that's impossible under normal physics. And here's where the name comes in. Oumuamua, from the Hawaiian language, means the first to reach out, or a distant messenger. Most people just call it the Scout. And let's be real, that name fits perfectly, because this thing wasn't just a rock wandering by, it was acting like it had a purpose. Now let's break down the layers of weirdness. If it were just an interstellar asteroid, its motion should have obeyed gravity, plain and simple. Passing by the sun should have drained some of its speed, not boosted it. So if it didn't slow down, that means something inside the object itself gave it an extra push. That's the part that blows scientists' minds, because that means it couldn't have been just a regular rock. Something else had to be going on. And then comes the next twist. Not only was Oumuamua moving in ways no one had ever seen before, but it looked bizarre too. See, when we image space objects, all we can measure is the sunlight bouncing off them. Planets like Saturn or Jupiter reflect tons of light, which makes them easy to spot. But small objects like asteroids? They usually just give off faint, steady blips of light because they're dark, rocky, and usually round. But not this thing. Oumuamua was unusually bright, way more reflective than any normal asteroid, which already hinted it wasn't made of ordinary rock. And even crazier, the brightness wasn't steady. It kept pulsing, flashing bright, then dim every 7 hours. That told astronomers one undeniable fact. This thing wasn't round like a typical asteroid at all. Its shape was something completely out of the ordinary. When scientists tracked the light patterns, they realized we weren't looking at a round rock at all. The reflections suggested two possibilities. Either the object was long and skinny, shaped kind of like a giant cosmic cigar, or it was wide, flat, and razor thin, like some kind of tumbling saucer spinning through the void. Now, if you tell people you saw a flying saucer from another star, they'll call you wild. Unless, of course, that really is what we just witnessed. So here's the big question. Was Oumuamua actually an alien craft? This is the part where the History Channel would be screaming yes, while flashing UFO graphics across the screen. But the truth is, we only know what the data tells us, and the data itself is bizarre enough. People obsess over the shape, and yeah, it's unusual. But the real smoking gun isn't how it looked. It's that unexplained acceleration. That's the piece that makes the alien theory hard to completely rule out. Here's why. Normally, only comets speed up near the sun, and that happens for a simple reason. Comets are basically frozen space popsicles from way out in the Oort cloud, filled with all kinds of random ices. When one swings in close to the sun, that ice doesn't melt into water. It sublimates, turning straight from solid into gas. That process creates the comet's glowing halo, called the coma, and the long, bright tail streaming behind it. But here's the kicker. When all that gas blasts off, it acts like a natural thruster. If the sun heats up one side of the comet, the escaping gas shoots out in the opposite direction, nudging the comet and changing its path. It's the same principle as a spaceship firing off boosters. That's why comets can accelerate in ways asteroids never do. But when astronomers looked at Oumuamua, they saw it accelerate without showing any of the usual comet signs. No tail, no coma, nothing. Just a silent, speeding, mysterious object defying every rule we thought we understood. But here's the thing. Oumuamua had none of the usual comet features. No coma, no glowing tail, no visible jets of gas shooting out, nothing. Yet it still behaved like a comet with invisible thrusters. That's why some people straight up suggested it wasn't natural at all. But maybe a spacecraft using technology we can't even detect. Now let's talk about where this visitor seemed to come from. Its path pointed right back toward Vega, the brightest star in the constellation Lyra, a star that dominates the northern sky. And Vega isn't just some random star twinkling out there. Astronomers have studied it for centuries, calling it one of the most important stars after our own sun. In fact, about 14,000 years ago, Vega was Earth's North Star, the steady light ancient humans probably used to guide their way through the night. Over time, Earth's axis slowly wobbles, so today our pole star is Polaris, but by the year 14,000 Vega will reclaim that throne again. Pretty wild connection, right? Now to be clear, we can't prove Oumuamua actually came from the Vega system. It only appeared to be arriving from that direction. And here's the twist. That happens to be the same direction our solar system is currently moving through the galaxy, which means, in a way, we didn't just encounter Oumuamua, we practically collided with it head-on. And this is where the coincidences start to stack up like a conspiracy board. A bizarre object flying in from the region of one of the most historically significant stars in the sky, moving in ways we can't explain, and then passing frighteningly close to Earth. Now, close in space terms is still far. At its nearest, it was about 24 million kilometers away, roughly 50 times farther than the Moon. But think about it. If this were some ancient alien probe, maybe it wouldn't need to get close. Maybe it could watch everything from a distance we can't even comprehend. Here's the kicker. We didn't even spot Oumuamua until it was already leaving. Our telescopes first caught sight of it a few days after it made its closest approach to Earth, already racing back into interstellar space. That means, for all the hype, we barely had any time to study it or figure out what it even was. Sure, scientists tossed around ideas about chasing it down, maybe launching a probe to catch up and get answers. But here's the problem. This thing was moving way too fast and had a massive head start. No chemical rocket we've got could ever hope to catch it. The only way would have been some insane maneuver, sending a spacecraft to Jupiter, slingshotting around its gravity, diving back toward the sun, then firing engines at the perfect moment to slingshot again straight out after Oumuamua. Sounds epic, right? But in reality, almost impossible. And honestly, if this were the one and only interstellar visitor we'd ever see, maybe it would have been worth trying. But just when everyone thought Oumuamua was a once-in-a-lifetime event, the universe threw another curveball. Because in 2019, only 2 years later, astronomers spotted a second interstellar object. This one was named Borisov, after the amateur astronomer who first discovered it. And just like Oumuamua, it came screaming in on a hyperbolic trajectory, moving way too fast for the sun to ever capture it. Even crazier? It also came from the same general patch of the northern sky, flying in out of the constellation Cassiopeia. But here's the twist. Unlike Oumuamua, Borisov looked and behaved like a classic comet. It had the halo, the tail, the gas, the dust, all the telltale signs. In fact, it seemed to be made of the same frozen stuff as the comets from our own solar system. Still amazing, but not the same level of mystery. And yet, what's wild is that for all of history, we'd never seen a single interstellar object. Then, suddenly, in just 2 years, we get not one, but two. And then, things got even stranger. Because before long, there was a third. And now we've got our latest guest from deep space, 3IATLAS. The name literally means third interstellar object, and it was spotted by ATLAS, short for Asteroid Terrestrial Impact Last Alert System. Basically, it's an automated sky survey system designed to hunt for near-Earth objects before they sneak up on us. On July 1st, its robotic eyes locked onto something big, fast, and coming straight our way. At the time of discovery, 3IATLAS was about 4.5 astronomical units from the Sun. For scale, 1 astronomical unit is the distance from Earth to the Sun, so this thing was 4.5 times farther out than Earth, roughly past Jupiter's orbit, but still way beyond Mars. Here's the exciting part. Unlike Oumuamua, which we only saw as it was leaving, we've caught this one early, on its inbound journey. That means we get to watch in real time as it swoops closer to the Sun for the very first time. What stood out immediately? Its size and its speed. This thing is huge compared to Oumuamua, and it's moving even faster. And get this, it's not coming head-on like the first two. Nope. 3IATLAS is coming in from the side, like some cosmic T-bone collision out of nowhere, which means it didn't come from anywhere near Vega or Cassiopeia. This thing was born in a completely different region of the galaxy, distant, ancient, and nothing like our familiar cosmic backyard. So let's zoom out for perspective. When we picture the Milky Way galaxy, we usually imagine that iconic spiral from a top-down view. Our Sun sits about halfway between the galactic center and the edge. But if you tilt the view sideways, the picture changes. At the core is a dense glowing sphere called the bulge, and wrapped around it is the galaxy's thin, flat disk of stars, planets, and swirling gas. That's where our Sun lives. But just above and below that thin disk is something different, a hazy, spread-out layer of older stars we call the thick disk. Not much star forming happens up there, but that might just be where 3IATLAS is coming from. 3IATLAS isn't just another space rock, it may be ancient. Its path suggests it came from the galaxy's thick disk, where stars and objects can be more than 7 billion years old, older than our entire solar system. That alone makes it incredible. But here's where things get crazier. First, the size. Atlas is massive. Its coma, that glowing halo of gas and dust, stretches about 20 kilometers wide. At the center, the solid nucleus could still be 11 kilometers across, 10 times bigger than Oumuamua and 5 times bigger than Borisov. Each visitor keeps getting bigger. Second, its path. Unlike the others, Atlas is cutting through the solar system sideways, which means it'll skim past multiple planets. It'll swing within 28 million kilometers of Mars, then pass just 97 million kilometers from Venus, and finally brush by Jupiter at about 53 million kilometers. In cosmic terms, That's uncomfortably close, and we'll be watching every move. 3IATLAS is making a full solar system tour, but here's the twist: it's going to miss Earth completely. When it swings by the inner planets, we'll actually be on the opposite side of the Sun, hidden away just as the comet makes its closest approach. That means by October, our telescopes will lose sight of it, and we won't see it again until December, when it's already on its way back out. Some say that's too perfect to be a coincidence. A planetary flyby that conveniently avoids the only inhabited world? To some, it sounds like the moves of an alien probe, slipping past planets to gather data while dodging direct observation from Earth. But if that were true, it raises the ultimate question: why would a probe travel billions of years across space just to ignore the one planet with life? Speculation aside, ATLAS is still giving us a rare chance. Unlike Oumuamua, we've spotted this one early. There's even a slim shot at an intercept, not with rockets from Earth, too slow, but with spacecraft already in place. Mars orbiters could shift for a closer look, or, in a long shot, NASA's Juno spacecraft might break orbit around Jupiter and try to meet Atlas in deep space next spring. It's unlikely, but if it happened, we'd finally know exactly what we're dealing with. Even without chasing it down, we can still piece together some solid theories. Let's say Oumuamua wasn't an alien ship. It could still have been a comet. But here's the trick. A comet doesn't have to be made of water ice like the ones we usually see in our solar system. Water sublimates into gas we can easily spot, which gives comets their classic glowing tails. But not every gas is visible. Take nitrogen, for example. It makes up nearly 80% of the air we breathe, yet it's invisible, odorless, and practically undetectable. And here's the kicker. Pluto, once considered the ninth planet, is covered in nitrogen ice. That's why Pluto looks so bright through telescopes despite being smaller than our moon. Frozen nitrogen reflects light like a mirror. Now imagine this. Pluto gets smashed by a giant asteroid or a rogue planet, and shards of nitrogen ice get launched into space. One of those shards drifts inward toward the Sun. Technically, it's a comet, but instead of water ice, it's almost pure nitrogen. As it warms up, it sublimates into invisible gas. No coma, no tail, nothing we can see. But invisible or not, the outgassing would still act like a natural thruster, slowly changing its speed and direction. In other words, it would behave exactly like Oumuamua did. And in this chaotic dance, the Sun's gravity slingshots the shard right back out of the solar system and into the endless dark. That's one way to explain Oumuamua. If something like a Pluto-sized world in a far-off star system, maybe even around Vega, shattered and hurled a chunk of frozen nitrogen our way, then, yeah, it would have looked and behaved exactly like what we saw. Or maybe, just maybe, it wasn't natural at all. Maybe it really was a 100-meter-long, cigar-shaped probe, tumbling through space, built by some intelligence we can't yet comprehend. It passed near Earth, close enough to stir our imagination, but not close enough to do anything we'd recognize, before slipping back into the void. And that's why 3IATLAS matters so much. This time, we get to watch an interstellar visitor as it approaches, not after it's already gone. We finally have a chance to test these wild theories, to learn whether these objects are icy shards flung across galaxies, or if something more deliberate is happening out there. Either way, the universe is showing us how small we really are, one pale blue dot in a cosmic story far bigger than we can imagine. The most exciting discoveries? They're still ahead. So if you want to follow every twist in this mystery, make sure to subscribe, like, share, and drop a comment, because this story is only just beginning.